Bismillahirrahmanirrahim. Let's solve this exam problem. A typical motorcycle emits about 20 grams of carbon monoxide per kilometer. This is how much mass is being emitted from the exhaust of the motorcycle per kilometer, 20 grams. The motorcycle traveled 5 kilometers. So the guy went from point A to point B, and it is 5 kilometers, and it is one way to his work. The problem is per meter of distance traveled. What volume of air could be polluted to the air quality standard of 9 ppm, and assuming that 1 mole equal to 24.465 liters. So, in order to solve this problem, we have to find the volume first. Okay, the volume of the pollutant. The volume is equal, first of all, he told you 20 grams of carbon monoxide per kilometer. Okay, this is exactly the estimate of the carbon monoxide that's being emitted from the exhaust of the motorcycle. And the traveling distance is 5 kilometers. So multiply this by 5 kilometers to find out the total gram of carbon monoxide that's being emitted. So kilometer with kilometer, now you have gram of carbon monoxide, 20 times 5. First, now we have to find out, because we need to find out the meter cubic of carbon monoxide that's being emitted. Now, we have to divide this by the molecular weight. Remember, molecular weight is gram per mole. That's why we have to divide it to convert the gram to mole. So you divide it. Remember, carbon monoxide has a molecular weight of 28 grams per mole. So you put gram down and you put mole up. What is the meaning of this? This is a mole of carbon monoxide, and this is gram of carbon monoxide. The meaning for this, you're going to cancel gram with gram. You'll end up with what? Now, mole of carbon monoxide. So the thing is going to be 20 times 5 over 28. Now we've changed mole to liter. It was given here that 1 mole is equal to 24.465 liters. So mole carbon monoxide equals 24.465 liters. So mole carbon monoxide with mole carbon monoxide. So now you'll end up with 20 times 5 times 24.465 divided by 28. That is liter of carbon monoxide. So now you change this to meter cube because he just needed per meter. So you're going to make the volume meter cube. So liter carbon monoxide, meter cubic carbon monoxide. And we know by conversion 1 meter cube is equal to 1,000 liter carbon monoxide, liter carbon monoxide. You'll end up with, at the end, with meter cubic of carbon monoxide. So this is how much being emitted for the 5 kilometers. So if you just multiply and divide, 0.087 meter cubic of carbon monoxide. This is for the 5 kilometer one way to his work. Now, he needed per meter distance of travel. He needed the volume of air that could be polluted to the air quality standard of 9 ppm. Okay? So let's look at the volume of the air per meter distance. First of all, let's look at the 9 ppm. Of course, 9 ppm, the standard, is equivalent to, since everything is in meter cube, we're going to make it 9. You're going to convert this 9 ppm to 9 meter cubic carbon monoxide by 1 million meter cubic contained inside air. This is the derivation of 9 ppm. It means 9 meter cubic of carbon monoxide over 1 million meter cubic of air that contain the carbon monoxide. And this standard, if you want to find out the volume of the air that could be polluted, is by putting this 0.087 meter cubic carbon monoxide over the volume in meter cubic air that will be polluted. So you're gonna do a cross multiply. Let's just call this X. Let's just call it X better. So you do a cross multiplication. 9x is equal 0.087 times 10 to the 6. So x would be equal to 9,666 meter cube. This is the air that will be polluted. But now he needed per meter of distance. Per meter of distance, it is by dividing the meter cubic of polluted air divided by meter is equal to 9,666 meter cube divided by 5 kilometer. One kilometer is equal to 1,000 meter, kilometer with kilometer. Now you'll end up with 9.7, so you could 9.666, 9.7 meter cubic of polluted air per meter. Okay, and this is it for this problem. Please, let's look at it and see if you could understand.